Hello, my name is Daniel Helfand, and I'm a developer advocate with GitLab, and today in this video I'm going to be going over GitLab's operational container scanning feature. For those of you who aren't familiar with this feature, what it allows you to do is to conduct container vulnerability scans on containers that are deployed to a Kubernetes namespace, and then have those vulnerabilities be directly reported back to your GitLab projects so that you can very easily view the container vulnerabilities that exist for your active Kubernetes environments. You may be wondering, why would I want to conduct these scans post-deployment? Why wouldn't I want to just do this pre-deployment, let's say in a CI job as part of a merge request that is open to a project? The answer is that you wouldn't necessarily just want to do one or the other. There are benefits to conducting these scans at both parts of the software development lifecycle. So for post-deployment scans, the benefit is that you are able to audit your Kubernetes environments in a way that you can understand fully what vulnerabilities are currently deployed to these environments. And it also helps you keep track of how software development teams are working towards resolving these container vulnerabilities with each new deployment out to their Kubernetes environments. The other really nice benefit of this is that these scans are conducted on a regular basis. So you're no longer dependent on needing to open a new feature to a project and run that container vulnerability scan as part of a CI process. Because these scans are running on a regular basis, you can have assurance that there's always going to be these scans being conducted that can pick up on new CVEs that are identified and then directly report these back to your GitLab project. So you're always staying on top of new vulnerabilities that are discovered as well. So if you want to go through this tutorial yourself, you can head over to the link that I'll pull up here. So you can go ahead and fork this project and follow along with the instructions in this video. You can also just go through the README here as well, which has the instructions that can allow you to get more hands-on with this feature. The first thing that we're going to do is go over the prerequisites that you would need. So first and foremost, you need a GitLab Ultimate account. You can sign up for a free trial that will allow you to experience a lot of the features of GitLab Ultimate. You'll need a Kubernetes cluster that is a particular version that is supported by GitLab. You can come to the link here to gain a sense of what those versions are and dig a little bit deeper into if the cluster that you have would work. And then you'll need the kubectl CLI and the Helm CLI. So the first thing that we're going to do is that we need to deploy a sample application out to our Kubernetes cluster. That way that we can have something that is running on our Kubernetes cluster that operational container scanning can scan for vulnerabilities and report those vulnerabilities back to our project. So just to show you that I've carried out the instructions in step 1 here, I'll go ahead and run this kubectl command against a cluster that I have. And you'll see that I basically have this sample application running in this Go web server dev namespace with these 3 pods running. So this is the namespace that will run our operational container scans on. The next thing that we want to do is that we want to configure the GitLab agent for Kubernetes for our project so that we have a way for GitLab to securely communicate with your cluster so that GitLab can basically receive information from your cluster, such as these vulnerability scans and the reports that are generated. So each time these scans are conducted, we want to make sure that GitLab is able to receive these results and that you can see them through the GitLab UI. In order to do that, you can come out to the project's config.yaml file here. This lives under the path .gitlab agents k8s agent config.yaml is the file here. And the only thing that you'll want to do in order to configure the agent for Kubernetes is that you'll want to update this ID property here. This ID property is only being updated because for this tutorial, you're going to fork the project to a group where you have appropriate permissions to run all the steps in this tutorial. In this particular case, I've just forked the project from where it originally was into my personal account. And so I've just updated it to have the path that it has now to make it really concrete. I'll show you the commit history here. I'm just changing it from where I forked it from to where it currently resides. So the point of doing this is that we want the GitLab agent for Kubernetes to be able to know where to report things like the vulnerability scans back to, right? Which project on GitLab should receive these results. So now that we've changed that ID property, the next thing that we'd want to do is that we'd want to configure this project to actually deploy this agent out to your Kubernetes cluster and then have it be set up so that's connected to the agent running on your cluster. In order to do that, we can come to this Operate tab and then click on the Kubernetes Clusters button. The next thing that you would do is that you'd click this Connect a Cluster button, and then you would use option 2 here to enter the name of the agent that you will deploy out to your Kubernetes cluster. In this particular case, you would use the K8 agent name here, and where that comes from is, if you remember the folder path to where our config.yaml file lives, it lives under this K8 agent folder. So we could name this agent really anything we want. We could name it something that identifies our cluster or our particular Kubernetes environment that helps make it a little bit easier to identify. In this particular case, for simplicity, we're just calling it K8 agent. The next thing that you would do is that you would click Create and Register button down there, and then you would be prompted to run a Helm command against your cluster to actually install the agent on your cluster. So in this case, I've already gone ahead and done that. You'll see here that I have this K8 agent registered with my project. The connection status is healthy. And then just for further confirmation that we're using the right agent with our project, you can see the configuration path here points to that K8 agent folder that we were just discussing. So the next thing that we'd want to think about is how do we configure the security scanning capabilities now that we have the agent successfully installed on our cluster. So if we come back to our config.yaml file here, you'll notice that in that same config file that we use to configure the GitLab agent for Kubernetes, there's also a container scanning section of the config file here. And then there's two important properties that we want to configure for operational container scanning. The first is this cadence property. So this configures how frequently do we want to run these container vulnerability scans. In this particular case, I have this cron syntax in here, which specifies I want to run these container scans every 5 minutes. In a more practical sense, you probably wouldn't want to run it this frequently. Maybe you'd want to run it every 12 or 24 hours. But to really highlight the features and to show you this working in action, we're doing it on a much more regular basis here. The next thing that you want to configure are the namespaces on your cluster that you want to run these security scans on. So in our case, our sample application is deployed to this Go web server dev namespace. And this way, through this namespaces property here under vulnerability report, we're able to configure all of the namespaces that we want to run these scans again. So it doesn't have to be just one, it could be multiple, but for simplicity here, we're just going to focus on where our sample application is deployed. So now that we've walked through how to actually configure everything with your GitLab project to run operational container scanning, let's go back out to our cluster to see how these scans are actually taking place and what the process looks like. So if I scroll up a little bit here, you'll see that I'm running this kube control get pods -n GitLab agent K8 agent -w command here. And what this -w is doing is it's basically an option to watch as pods come up and are spun down in this particular namespace. So this namespace is where the GitLab agent is deployed to that we deployed in a previous step. And then you'll also see that in addition to these pods for the GitLab agent that is running, there is this Trivy scan Go web server dev pod that is being spun up. It runs, it completes, and then it terminates. And it seems like it's doing it pretty frequently. So this is going to occur every 5 minutes as we configured as part of that cadence that we set up in that config.yaml file. And then the Go web server dev addition to the name here is just signaling which namespace we're running the scan against. So this pod is going to use a tool called Trivy, which is a container vulnerability scan, and it basically will conduct the scan on all the containers that exist within our Go web server dev namespace. Once the scan is complete, everything is sent back to our GitLab project, and then the pod terminates. So this is what it looks like to actually run this on your cluster, is that the GitLab agent is just continuously spinning up these pods. It runs the Trivy process, and then everything is sent back to your GitLab project, and then the pod is spun down. So the last thing that we want to do in order to actually see the vulnerabilities that are revealed from our scans is to come out to our secure tab here of our GitLab project, go to the vulnerability report button, and then we're going to click on this operational vulnerabilities button. So you're seeing here that there's quite a lot of vulnerabilities that are reported with this particular container image. You'll see here that the image name is located under the description of what the CVE that is revealed is. You get this nice information about the severity of the CVE and how soon you should look into addressing this particular vulnerability. And then you'll also see information about the cluster. So in our case, this corresponds to the agent name that we have. It gives you a sense about where this vulnerability is actively deployed to. So within this dashboard here, you just have all this information about the CVEs, what particular image is affected, and where that image is actively deployed to, all from your GitLab project. You can also further drill down into the CVE, get a nice description about what the particular vulnerability that has been discovered is, and then you have the option to create a follow-up issue in your GitLab project with the button down here to create an issue so that your team can be organized in how it's prioritizing fixing the CVE. And then you also have the ability to add the context here to an existing issue if you know that there's going to be some change introduced to your project that will resolve this particular CVE. So I hope this video was helpful in helping you understand a bit more about GitLab's operational container scanning feature. If you want to get more hands-on with this, definitely create a GitLab Ultimate account that will give you the ability to fork this project here and walk through the tutorial yourself. I hope that this revealed some new and interesting ways that you can improve your Kubernetes security practices. And I thank you again for watching this video.